typical question on the test. X squared plus 6x plus 5 all over, everybody write this down, x squared minus 25. But here's the tricky part. Plus, that is pretty easy, really. That is easy. You factor it, some stuff cancels, but then you got to add 3 over x. Why does that make it more complicated? Because they don't have a common denominator. I would factor first, right off the bat. If you can factor it, you should. And then you can cancel some stuff. A lot of people wonder, can I cancel? Because it's like it's part of an add problem. That's the difference. Is if it's part of an add problem, you could only cancel inside here. Like, let's say there was a 3, or you could factor out of this part. You couldn't cancel with that because it's part of an add. But if you stay inside the big red parentheses, you can cancel stuff in there. Then you get a common denominator. That's the part I think will stump more people. I know you know how to factor. I know you know how to cancel. But do you know how to get a common denominator? First, get it all simplified down into what 2 fractions do you have left. And then ask yourself, what could I multiply the right side by that would make it like the left side? And vice versa. All right, I'm confident you guys had x plus 5 and x plus 1 over x minus 5, x plus 5. I'm confident you had that. But, and I'm even confident that you canceled this, because you know that's why we factor those things and stuff like that to cancel. But from here, I'm going to clean it up a bit. I'm afraid some people would be stumped right here. I'm going to pause while you turn and talk with a friend about what you think needs to be done to be able to add them together. Pausing.
I made it more complicated.
All right. How many of you realized you got to go with x plus 5 on the top and bottom over there on the right-hand side? Raise your hand if you realize that. You were right. And then some of you are, actually, I said plus 5 because he said plus 5. Dang it. X minus 5. My bad. I hope you knew that's what I meant. We wanted this and this together as the common denominator. So now this side needs an x over an x. How many of you did that? Okay. Why did we do that? Because now look, they're the same. X times x minus 5. X times x minus 5. They're the same. That's the point. We have a common denominator. And then, to actually multiply this out, there's imaginary parentheses. I'm going to make them red here. They are what's called implied parentheses. All right, so this is going to be x squared plus x. And this is going to be 3x minus 15. All over the denominator, which is x times x minus 5. Now, I'm not done yet because I can get some things to be in common and put them together, but I'm close to done. That's going to be 4x, and I'm pretty sure I can't factor with a 15. I can't make a 4x. So I'm pretty sure that's it. Now, if I could factor the top, I would, because then I might get stuff to cancel. But because if you can factor it, you should. All right, raise your hand if you had that one right. Oh, that's most people. Cool. All right, I'm going to give you one more that's quicker, but still gets across the same point. Get a common denominator and add them. The multiply kind are actually extremely easy because everything just kind of cancels and it's no big deal. The common denominators are tougher for kids. Decimals. Who should I call on? Row 5, fifth person. Person in the back. What do you multiply the left side by over here? You are correct. Why is it legal for me to multiply by x plus 2 there? Because, yeah, x plus 2 over x plus 2 actually equals 1. That's why it's okay to do that. All right, next. Row 2, person 4. It's you. I know you've been gone, but you can handle this.
Okay, so it'd be x plus 4.
Yeah, it's not that hard. And then they have a common denominator. So my final answer has that denominator of, and notice me not multiplying it out, because it's factored, and factored form is better anyways. On the top, you might think the same logic would apply, but on the top we can have to add it all together first so that we can factor it. I know this part's factored and this part's factored, but they don't have any common factors, so we can't factor it further. So we want to multiply it all out. X times x, x squared. X times the 2, 2x. X times the 1, x. And 1 times the 1, 1. And if I put these together and say 3x, that's even better. And then that gives me a chance to factor that top part. Can it factor? No. So then I'm done. That's it. Over. Okay, so the other part that we learned last, the most recent thing we learned, is things like this. And I'm going to give you a 2-second reminder on how to graph that puppy. Here's the parent, which would be y equals 1 over x. And if I wanted to do all of these steps, the first thing I would do is this negative that's in the front. See this negative here, guys? I get you trying to help somebody with math, but when you talk at like a normal volume and I can hear you easily from here, that's the problem. Whisper. Because otherwise people can't, behind you, they can't hear me teaching the new stuff. So even helping somebody with math is bad if it's loud enough to interrupt up here. Okay, so back to that negative there tells me to do this part. Do you get what just happened? I could either say that that got flipped this way or this way. It wouldn't matter. Because a horizontal or a vertical reflector are the same exact thing. That's my first step. And then I move it 3 to the, what's that? Left and up 7. Here's 3 to the left. Thank you. Sorry, 3 to the left. And then up 7. There. And then I'm putting my asymptotes. You hopefully, whoa, I don't like that kind. I'm going to try dotted. Because that's what asymptotes usually are. There we go. And here we go. And I hope you remember that the ones that are like the x-axis are not x equals. This is the this is the x-axis, so it's y equals 0. So up here, this is y equals, and then think about it. How far up did it move? So it's y equals 7. And now people get confused sometimes on horizontal versus vertical. Is that a horizontal one? Is it like the horizon? Yes, so that's horizontal. Okay. The vertical, the green one, that's kind of like the y-axis, but the y-axis is actually x equals 0. And so this is an x equals line. And how far did we move it to the left? 3, so it's x equals -3. And you know that's kind of counterintuitive, but it is the opposite of what's in there, right? It's supposed to be always opposite of what you'd think. So, okay. So there's my horizontal and vertical asymptotes, and I graphed it. And I only require 2 distinct points on these as long as your asymptotes are in the right spot. It would be that spot and that spot, which is over 1 and up 1, and over 1 and down 1. Those 2 key points. All the rest of the points can just be like, again, this sketch. This can be just like, as long as this line gets closer and closer, and as long as that line gets closer and closer, it's good enough. But you need a distinct dot there and there. And I'll draw these in a little nicer. There we go. Get that black one out of there, and now there. There's my final answer for graphing. That's a big part of your test. So what's left? What's left to teach you today is about holes in graphs. So I would like you to find the file that's posted for today, and I will use some of those problems. It's got today's date on it, which is 12-17, and it mentions holes in the title. Pausing. Here we go. So we found the right place. I'm actually going to cut down this size just a little bit. Let's go 75% off. There we go. I can hold the whole thing. You now have the same exact graphs, except they have holes in them. I'm going to help you understand how this happens. There are times, okay, the old walking down the street thing. No. Unless you meet up with like Bill Gates and he's just deciding if he wants to like, hey, tell me how you end up with a hole in your rational function. I don't think it's likely walking down the street that you're going to need to know this. But if you wanted to know just all the math that you needed to know with it that was going to happen in your real life, it pretty much all you'd really need to be good at is through algebra. Really? That was through algebra. That included up into algebra. Okay, but we're going beyond that because I'm hoping that some of you can be our doctors, engineers, physical therapists. Yeah, you'll have to pass calculus to do that. Yeah. Anything that's got like a professional degree, you're going to have calculus. All right. So this hole here. Too much talking. Focus. Gentlemen. Thank you. All right. So I got to tell you how these things happen. And I think the best way is to show you a typical question where it happens. So find this one right here. And factor the top, and the bottom's already factored. So, or you could say it this way, you can't factor the bottom. So, and you have it won't let me change that. Minus 4. There we go. X minus 1 and x minus 4. And then what happens? These cancel. Now, what's different than before? Before, you'd have had a problem like this, and there might have been an x plus 1 on the bottom, but it wasn't canceling with anything. On that kind, it made a vertical asymptote at -1. Because you remember me saying you don't want that bottom to be -1. Because at -1, you have an asymptote. And I can look at that x and go, I know it's vertical because I say zertical. Remember? Okay, so that's a vertical asymptote. This does not create a vertical asymptote. Why? Because it cancels out and leaves a function behind. Remember, f of x is like y, right? So y equals x minus 4 is left behind. It's not like everything just dies. That one little part right here cancels out, and it leaves behind a resulting function. If I were to graph it, do you guys get that this would have a y-intercept of -4 and the slope of 1? So it would look kind of like this. But it has a hole. Even though that's canceled off a while ago, it's like it's in its past history. It had a weakness for the number 1. If you put in a 1, it would have crashed the function. But every other number works. So here's what you do. You go to over 1, and you say, at that spot, it doesn't work. So you put an empty spot right there. So this function works everywhere except 1. But why? Well, because do you get in the original function, if I put in a 1, look at it. Isn't it going to crash? It's going to have a 0 on the bottom. So clearly 1 doesn't work. You get that part? Now the only question is whether that creates an asymptote or a hole. Because we know it crashes the function. It's just how does it crash the function? Does it crash it by making a hole? Well, if there's something on the top and bottom that are identical that cancel each other out, that's the kind that end up being a hole. And the kind like this, where nothing cancels it out, that's the kind that are an asymptote. So I'm going to show you two more. If I were you, I would just add a blank page for a second. Do you get that this one would crash if I put in -8? And that's the only kind you knew of before today. Because nothing's canceling that out. It's just going to crash. That's the kind that gives an asymptote. This one has a vertical asymptote at x equals -8. This kind with another x plus 8 on the top, that kind's going to be similar but different. Because this kind has something to cancel it out. And do you get there's still something left? Y equals 1. Except it still has a weakness for -8s. See what I mean? Even though you can't see it anymore, you know in the original function, if you had put in a -8, it would have died. This kind has a hole at x equals -8. Most people get this after a while. It's not too hard. If they cancel out like this, that's the kind that makes a hole. And if they don't, that's the kind that the -8 makes an asymptote. That's all there is to it. Now let me tell you the part that is the most marked wrong on the test. I'm not saying that you can't do it. I'm just telling you, from my experience, I mark this wrong more than anything else on the test. Because people don't know what to do to find the other part of the hole. Would you agree a hole is a space, a place on x and y? It's a something comma something. Well, I already know the x of it. It's -8. Most people get that. But they don't know how to figure out the y. Here's what you do. You're right. You stick it back in. You stick in the -8. But some people are like, where in the heck are you going to stick in the -8 here? Here's the way I'd say this. No matter what you stick into this equation, y is always 1. So y has to be 1. We already knew the x, but what is y? See, y equals 1. How am I supposed to have it be anything else? Y is just always 1. In fact, if you look at the picture of this, if I make a graph for you, and I say, here's the graph of it, do you get that wherever that hole is, x could be, well, anything, and y would always be 1. So let's talk about x equals -8. That's over here. So here's -8. What happens there? There's the hole. What's the y of the hole? It says y equals 1. It's got to be 1. All right, I'm going to give you another one that's a little more complicated. It's just got a 2x with its x plus, let's say you get 6 this time, just to add a little bit of variety. So right away, kids notice that -6 is an issue. Most kids figure out that that's the special kind where this cancels, so the -6, it makes a hole. And then the bad ones, the kids that don't get it really, might just say -6. If they ask hole, they'll say -6. No, not good enough. They have to say, what's -6? X equals -6. That's kind of the medium kids. They know that x equals -6 is where it makes a hole. But the ones who actually get the A's on the test are able to take one more step. And that is, if x is -6, what's the y? Well, y is equal to 2 times x. If x is -6, you can put it right there, and you get -12. Some of you may not even get that today, and it's okay. You can even get an A on the test without knowing that. You just have to know everything else, but holes are important enough, but they're not that important. You could not understand that and still get an A. But you have to understand it because you might make a mistake somewhere else, and you can't afford to have too many things you don't understand. All right, so one last time. Why wasn't that an asymptote? Well, if it didn't have this top part, the -6 would have been an asymptote because nothing's canceling it. If the problem had looked like this blue problem now, then it would have just had an asymptote at -6. All right. So one more thing that sometimes blows people's minds. And let's say I make one of these things cancel, like that. And then I make this make this x, and make this x plus 7. Okay. I can usually get people to realize this has 3 weak spots. -3, -2, and -5. Do you get all 3 of those things? We cancel my function or kill it. Okay. But one of them is making a hole when it's not working, and the other 2 are making asymptotes, vertical asymptotes. What does that imply that you never knew before? You can have 2 vertical asymptotes on a function. Up until this moment, you had only ever seen one where there'd be one asymptote running like this, but you can have 2. Yes? Yes. All right, so first, are you getting that those cancel? So then there's a hole at, and I always encourage kids to just write the hole like this so they don't get trapped into like thinking x equals 3 is a good answer for the hole. -3, comma, and then what? Well, I don't know yet. How do I figure it out? I stick the -3 back in the function. This part's gone. So I put the -3 here, and here, and here, and here. And I simplify it all down, and I get a number. And that goes here. I'll check. 4 times -3. And this one, -1 times 2. So -12 over -2 makes +6. That's the hardest thing. Okay, and then what about the other things? You said there was 2 other asymptotes, server? Yeah, -2 and -5 also crash this function, but they don't get canceled off. So -2, like let's say this is this dotted line here is at -2. I'll just move it over a little bit. And then the other asymptote would be at -5. Got 2 asymptotes. What do they look like other than that? Well, here's a typical one. This last thing you don't learn until tomorrow. The last thing is tomorrow. And that's how to find where the horizontal asymptote is on one like this. This one is at y equals 1 is where the horizontal asymptote is. You'll learn that tomorrow. And then it goes like this. Would you agree that the lead coefficient is positive? Like there's no negatives in this whole thing. So then it's going to be going up on the right. Okay. So, well, at least the answer must be in this quadrant right there. So the graph must be over there. And then, to be honest, I'm not even sure where it is, but here's a typical, it would take me a while with an XY chart, by the way. It's just connect the dots. You just find a bunch of points, and I could do it, but it'd take me like 10 minutes, and yeah, that's what you're going to have to do. Actually, not till pre-calc, though. No, you're not going to have to do anything this hard on this test, no. But just so you know, they can have 2 asymptotes, and a lot of times their answers look something like this. All right, I said that the hard ones like that are going to be on pre-calc, but you are going to have to be able to say, this one has 2 asymptotes. You wouldn't have to draw one this complicated as this. All right, so let's do a real question from your homework. I think it's about that time. So everybody find the homework that has been posted for today. I'll pause for a second while we do that. Okay, and as usual, I am going to cut down your assignment to a more reasonable size.
Press 2 whole columns and I will do it.
Focus. Sorry. All right. So you are doing the odds. So you may cross off not all the evens, though, because I'm going to do a bunch of them with you. And the way it would work is there's a few where I would be doing the only one that's like that, and you need to be able to practice one yourself. So you can cross off all the even ones except you're going to do number 8 and you're going to do number 16. Because there's questions like that, you need to know how to do that kind of question. I can't just keep it simple and I just skip all the even ones. You're skipping all the even ones except 8 and 16. All right, so let's get started. Number 1. If you can factor it, you should. X minus 2 over 2 parentheses x, or sorry, that's a 3. There. Does something happen? Yes, and when it cancels like this, you've never known this before because we never graphed these before. But when these were canceling out, what were they making? A hole. And the hole, what is the thing that causes my function to crash? 3. So the hole is at 3 comma, and how did you get that 1/3 so fast? Where did you put the 3? It's not right, by the way. Oh, I'm not right, actually. Sorry. That's supposed to be a 3. And it's just because this is weird, but when you're too close to the board, it's really hard to read that 3. It looks like a 2. From right here, I swear, from this angle, it looks like a 2. Okay, anyway. 3, because it would make it 0 on the bottom, especially. The top being 0 doesn't really matter. And then what's the other number? Well, when you put in what's left, look, this is gone. What's left? There's a 1 up here. It's y equals 1/3. It's not giving you any choice. No matter what you put in, y is 1/3. So it's 1/3. Normally, I'd say stick the 3 in. Where are you going to stick it in? You can't put it in for the y. It's the x number. So no matter what you put in for x, y is 1/3. All right. The next one is very much like that. I don't want to do it because you need to do it. You keep going and you do number 3. And check with the kid next to you. I'm going to pause for a second while you try number 3 and check it with the kid next to you. You know what I think the most common mistake is? People don't finish it and say, what's left after that canceled? Y equals 2 is what's left after that hole canceled out. So where's the hole at? The hole is at -3, comma, and then you're trying to figure out what y is, and it's like screaming it right over here. Y is 2. 2. Raise your hand if you had -3, comma 2. Okay, awesome. All right, the next one's just got a tiny bit more complicated factoring. And I bet you there'll be a hole when something cancels. And then don't forget to write the resulting equation. Like after that x plus 2 cancels, maybe it's like x plus 6 or something. I'm not saying that's it. But figure out what's left after the hole canceled. That'll tell you. I know the hole's at -2 comma something. I can tell just by looking at that. But I don't know what the other part is until I stick it in the function. So this part's not right. I told you it was not right. -2 comma something. You figure out what's the resulting function. All right. The reason you have to do number 8 is that I'm going to show you number 7. Because from what I found, there was only like 1 kid in the whole hour could do number 7. So let me help you with number 7. Number 7 is assigned. Because you can't just sit there and watch me. You just have to write it down. I'm going to show you, though, so you can easily get this one. All right, if it has a vertical asymptote at x equals -3, who could tell me what that means? Yes, one thing at a time. X equals -3. What does that mean? Yeah, it's an x plus 2. Not just somewhere. It has to be on the bottom. Because, see, -3 is going to crash my function. And there's another one at x equals 0. A lot of people like to write it this way. Or x plus 0, and it doesn't matter. X would have been just as good. But lastly, there's a hole, and there's nothing on top. Well, I would never leave it with nothing on top. I'd just stick a 1 up there. But there's a hole, so that tells me there's one more thing. And do you get that that's something on top of something so that they'll cancel each other? So that's going to be, what do you think? And then what do you need to be an equation? Y equals, or f of x equals. And there we go. And if you're like, but there's still nothing else, we'll put a 1 up there if you want. So that when the x plus 1 cancels, you'll be left with a 1. But you don't have to have that 1. It would be there anyway. There. I did number 7, and that's the right answer. So you use what I just showed you. See if you can do number 8. It's got 2 holes. 2 separate things cancel. It looks just like number 7, except you gotta learn from what I taught you in number 7. All right, I think that's enough help. Remember, you're doing the odd ones, except you have to also do number 8 and number 16. Tomorrow, you're going to learn the last new thing. Wednesday's review, test Thursday. Test is planned for Thursday because we know there's going to be a lot of people gone on Friday. On Friday, the simplest thing would be like, let's have a party, but no. Mr. Erickson has specifically said, don't have just a fluff day on Friday. Otherwise, too many kids are going to say, well, I don't even need to be at school on Friday. It was a waste of time. So, well, you can have a fluffy day in there. And then here you'll just have one thing to learn all day. So, it's just review. It's a review for the cumulative. Because there's a cumulative coming, nothing new to learn, but there will be a review for the cumulative. And then after break, we don't just boom, here's the test. After break, we still give you a day of review for the cumulative. And then we take the cumulative. Okay, so that's the plan. That's all that's left, by the way. Tomorrow, last day of new material for the semester. Yes. So we have a few days to review and then a cumulative test, and then a few more days to review and then the finals. So we actually have way more review days than normal built in for this final. So yay, you got that going for you. GL.
For, if there's multiple asymptotes,
Yep.
domain, will you just write it
Good question. Let me show you the domain on number 7. I know this is not the question you're asking about, but let me just show you. Do you agree that the only 3 things that wouldn't work would be -3, 0, and -1? So if I was writing a domain, which yes, on your homework you'll have to write a domain. The domains for these are, it works from -infinity until it hits the first number that doesn't work. What will be the first number that doesn't work? -3. And then it works again starting after -3, and you put a little u in between, until it hits the next number that doesn't work. Technically -1. And then it keeps going until it hits the next number that doesn't work. And then it keeps working from 0 to infinity. That is a pain in the butt, but it's not that hard. It works till it hits -3 and -1 and 0. That's a way to think of it. I know this is a little intense, but remember, I only have one more thing to teach you, and then we have I'll just review until the test. Okay, so tomorrow is the last day of new material. And then we have just reviews and tests. And the cumulative test really is a retake. So if you've had a bad test, you can use it for a retake. Yes, go ahead. Okay. That's all I got for you for today.